The topic is going to be about the static coefficient of friction. Friction force, as you know, can be classified in two types. Depends on the status of the object, static versus kinetic. So in other words, static friction force, when associate with the friction force whenever an object does not move, whenever the object is in rest. Kinetic friction force, on the other hand, just represent the dragging force whenever the object is in motion. Friction force in general is again associated or proportional, directly proportional with normal force, with that coefficient. It's mu, and the mu represents just coefficient of friction. We are going to talk in details about it. But in case we have like a static, that's going to be like a static friction force. Kinetic is going to be kinetic. Now, what the difference between them is just, it even though both depends on the type of the surface, the type of, the contacting surface where they slide on each other, but the static is just whenever the object is in rest, versus kinetic whenever the object moves. This graph, guys, what you see is just representation, or the relation between friction force versus applied force. And there are two interested regions. This graph can be just represent the two different cases: static friction versus kinetic friction. Now, as you see, the static friction force increases as the applied force increases, and it's going to be something like this till to reach the maximum value where the object start move. In other words, the maximum static friction force is just whenever the object start move, start sliding, and then the static friction force is going to be at maximum. And guess what happened? At this point, the friction force will drop a little, drop as the motion starts sliding, and then now the friction force is considered as a kinetic friction. Let's investigate this graph. By yourself. So I'm gonna give you now, guys. I'm gonna give you every group with this spring balance, just to measure the applied force, this big F, versus the friction force of that block with table surface. So what you're going to do is just to hang out that spring scale with the block, and then try to pull it kindly with to a certain direction. You will see at the beginning the forces increases, to reach the maximum value. The maximum value of the spring scale, it just indicate where or when that block starts sliding. And you will notice also that this maximum value is going to be reduced, is decreasing, in other words, whenever that block start sliding. So go ahead, guys. I'm going to give you like maybe a few minutes just to check that by yourself. Do it with your partner. Just partner, your partner. Watch that spring scale, how the forces generate, or varies with the applied force, and check if that graph does make sense for you. Now, again, the friction force is just like is the force generated due to the contacting of the surfaces. So it's naturally it depends on the type of these surfaces. The following table that you guys see, and this table, by the way, is just provided in your book, illustrates some typical values for these coefficient of friction. The first column is just the static friction force, or the static or coefficient friction force, versus the kinetic coefficient of friction for some given forces. For example, and these vary depends on these surfaces. So, for example, glass on a glass, we have like static friction force is 0.94 versus 0.4 for the kinetic coefficient. Anyway, if you just notice from that table, you see static coefficient of friction always bigger than the kinetic coefficient of friction, because again the static friction force is going to be the maximum value, and then whenever sliding starts, the friction force is reduced because the kinetic coefficient of friction is lower than the static friction force or the static coefficient of friction. So the numerical value indicates that the coefficient of friction has values range from 0 to 1, where 0 is the minimum friction, in other words no friction, 1 is going to be the maximum. So that coefficient is just like a scale defined by the surface and defined by the condition. Assume you are holding a physics book in this way, hold it on the wall. Now, of course, the force that hold the book on the wall is the friction force between the wall or the board with the book. So there's a friction force, and that friction force, the spike, is that the hold the object from falling down. Now the question is, what is the direction for that? That force which hold the book must be directed upward, just to hold it up. Otherwise, the book again will fall down. So that force must be directed upward. Okay, let's start with the static coefficient of friction, and let's just take a look on the following example from the textbook, the experimental determination of both mu s and mu k. That example is very basic. It's just illustrate a mass placed on an inclined surface, rough surface. In other words, there's some friction on that surface between these two surfaces, and we will check how much the static coefficient of friction in such a way that the block just start to sliding down. In other words, just before sliding down, and that can be easily determined according by using Newton's law. In other words, just you do like a free body diagram for the applied forces. We have we have three forces acting that block: gravity or the weight going downward. Normal force is perpendicular to that inclined surface, and the friction force is directed up in this way. In other words, it's going to be opposite to the sliding down. Applying Newton's second law to this situation, just in horizontal and vertical axis, leads to the following couple equation. Horizontal forces is just mg sine theta minus, because it's opposite, the friction force equals 0 at the moment just before the sliding happened. So no acceleration either in x direction or in y direction. Okay, so two simple equation, no acceleration. These two equations can be solved for friction force as follow. We can easily find the friction force given by normal multiplied with tan this angle theta. But remember, the friction force is given by static friction force multiplied with normal force. Then it can be simplified just to mu s, the static coefficient of friction, equals tan theta critical, theta sub c. Theta critical is the angle again where the object starts to sliding down. So it's just like movable inclined surface. We can just raise it up till to check or to see when that wood block slide down. So what we need just to know what is the critical angle, how much that critical angle, take the tan of it, and then we can compute easily static coefficient of friction force. Okay, very simple technique but very efficient again. Thank you so much.